give a warm welcome to Google staff software engineer Brendan Burns.
Hi there. Thanks for coming this early in the morning. I'm from the Pacific time zone, so it's even an hour earlier for me, so I appreciate everybody showing up. I'm going to talk about management at the Google scale and how that relates to some of the stuff that we see developing in the open source world, and Salt in particular. But first I want to give people a little bit of overview of the Google Cloud Platform. There's going to be a talk right after the complete session at 9:45 that Eric Johnson is giving that's going to go into some of the details of how you run Salt on the Cloud Platform and other aspects of the Cloud Platform from our storage offerings. Oh, next slide. From our storage offerings to some of the app services like BigQuery, things like that we offer. So he's going to give some overview of that so people can get oriented, but I thought I would just highlight some of the things we have. A lot of people may have heard of App Engine. We just recently went to general availability with Compute Engine. It's a virtualized machine environment. You can get a Linux virtual machine with network load balancing, persistent disks that you can attach, all that sort of thing. That will be overviewed in much more detail a little bit later on. So for really, as long as Google has been around, we've been building scalable web services. We've been building out infrastructure to support literally billions of people a day, using our services and having to have the resources and managing those resources and managing that software in order to be able to support all of the search and everything else that Google is doing. And in doing that, we really, in some ways, had to invent cloud computing before cloud computing existed. We built data centers that are physically remote from where engineers are working, and the interactions that I've had with every single server and every single software that I've ever written for Google has been over the network. I have literally never seen the computers that my software runs on. And so, as a result, we've had a great deal of practice in cloud, and we're starting to bring that to the Google Cloud Platform as a whole. It actually took us a few iterations, I have to say. Like in the course of developing the software that we use now, there were definitely, and you can see the iterations in some respects. If you look back historically at the iterations that we went through, you can see the iterations happening in the open source community and in the general cloud community as a whole. That's pretty exciting. Okay. So what have we learned along the way? There's three things I want to highlight. One is that there's a real imperative for declarative management, and I'll talk in detail about what I mean by declarative management and draw a bit of a distinction between that and a more imperative style of management. The next piece is that we're really big proponents, in some sense we're the originators of the notion of a container, so at least in the Linux environment, and I'll talk why declarative management and containers are quite a really powerful combination. And I noticed later on there's a talk on using Salt and Docker. I'm pretty excited to see what other people are using out there. And then finally, we're going to talk a little bit about how when you take a step into declarative management and having containers, you need to have introspection as well. You need to be able to essentially forget about SSH, and that's something that I did over my time at Google. All right. So a little bit about me, just to give you a little bit of perspective. I've been an engineer at Google for about 6 years. I was primarily in web search infrastructure until I switched to the cloud platform about 1.5 years ago. I built the backends for real-time search, Twitter search, if you remember that. Had a little streaming thing for a while. Google Plus Search, and a bunch of other kinds of search infrastructure. A focus on recent events. So if you see search results that are under a day old in Google, when you search for anything in Google Plus or anything else, you're using software that I wrote. So it's pretty exciting. More recently, I've been working on cloud infrastructure. And all along the way, this is a real contrast, to be honest, from when I started. When I started in the software industry, we went to Sun and we basically opened our checkbook and we wrote the biggest check that we could to Sun Microsystems, and they gave us a computer that was supposed to never fail. When I came to Google, we build software to expect failure. We build software that we expect to fail at the machine level, at the software level, at the network level. It doesn't matter. And the other aspect of this is I carried Pager for web search for the years that I was on web search, and I never had root access. Right? I never needed to SSH into those machines. I never, despite having it, it's not that the pager went off. It didn't go off. The pager went off a lot. But the management that we were doing was such that I did not have to have the kinds of access that you might traditionally have onto a physical machine. All right, so I'm going to talk a little bit now about declarative management. And as a contrast, I want to talk about sort of imperative management and the development of Snowflake servers. So at the extreme level, a Snowflake server is something where you've created that virtual machine or that physical machine, you've SSH'd in, you ran apt-get, you went for coffee, you ran for apt-get again, you tweaked a config file, you did a bunch of very manual steps in the command line and with an editor, and at the end you have a perfect server. The trouble is it's also perfectly unique, and eventually it's going to melt. And when it does, you'll have forgotten 3/4 of those steps, and even if it hasn't melted and you're trying to reproduce it for a development environment or for a canarying environment, you'll forget the steps that you did. And I've done this so many times where I'll have something set up and I think it's ready, and it'll turn out that there was this one step that I forgot 3 weeks ago that I did that made that thing actually work, and I go to do a demo and it doesn't. So there's a real need to do declarative management to focus on, and the distinction that I mean by that is that you focus on the desired state of the system, not on the instructions that take you from a raw system to the state of the system that you want. You define the desired state, and you trust that there will be a system of actors that take the system to that desired state. And I'm going to talk a little bit more about how taking that step actually, so the first reason you take that step is because you don't want to be in that situation where you've forgotten what you've done, but by taking that step, it unlocks a whole bunch of potential for additional tooling and more reliability and everything else like that. So the first thing that declarative management really does is it separates out the design of the system and the space that you're thinking about the system from the physical manifestation of the system. So as an example of that, what you'll see up here is you have a circuit diagram for a binary clock. You have the physical manifestation of the binary clock. No one who's building that binary clock hauls out a bunch of wires and a bunch of chips and just sort of starts wiring things together. Right? They work in the abstract space of the circuit diagram until they have the circuit that they want, that they like. Then they manufacture it to make the physical object that you have on the left. And I think that this is the exact same analogy that you want to have in computing. You want to reason in this space of the declaration of your desired state. And then trust that someone, probably not even you, can actually make that desired state into reality. And the first step, you do it, as I said earlier, because you want something that's reproducible and you want something that's reliable, but it turns out that the actual mental shift to a declarative state actually changes the way you, at least for me, really changed the way that I started to think about configuration. Changing it to be a text file that I was editing suddenly made me start thinking about things the way I thought about software. I thought about modularity. I thought about, hey, I should really make this database module into a piece that I can reuse later, because right now I'm doing a Node.js server that's connected to MySQL, but sometime later I might want Tomcat connected to MySQL, and I need that MySQL module to be something that I can take and I can lift across. Or I may think about refactoring in a way that I might think about refactoring in a server. I might think about, hey, this thing, it's one giant file, it's too complex. I need to refactor it into logical entities so that when I'm in a particular desired state, that's the desired state that corresponds to my database. That's the desired state that corresponds to my web server. All of these things happen, I think, only when you start thinking about things in the abstract and think about things in a declaration of a desired state, rather than when you're dealing with the actual physical or virtualized thing that you're playing around with. So that's the first important part. The next important part of taking this step to this declarative desired state that's in a text file is it unlocks a lot of tools that you are already using for software. Right? It unlocks code review. Right? Every single config change that I have ever made to a production system at Google went through a code review process. It went through a process where other engineers took a look at it, looked at the diffs, and eventually said, maybe you should do this, both from a stylistic perspective, so other people who are reading the configurations can understand my configuration, but also from a correctness perspective. Hey, I really think that maybe you shouldn't be connecting production web search to that testing database over there. Sorry, I copied and pasted that, right? Those are the kinds of things that code review. Just as they find bugs in software, they find bugs in configuration. And the other part of it is it gives you an audit trail, right? So even if you didn't go through the code review process, using version control, using tools that provide you with a record of the changes that you made, as an audit trail, not just of who made that change that broke everything, but also what are all the changes that I made to get from this point to this point so that I can replicate those changes at some other later date. So again, you step into it, it changes the way you reason about the system, it changes the mechanisms that you can apply when you're building the system. And finally, it really, I think, facilitates reuse. And it facilitates reuse in two ways. When you're talking about this desired state, it becomes very easy to say, well, you know what? My development state is really my production desired state, but with this one small change, which is that the number of machines I want has shrunk by a factor of 10 because I'm not going to run production workloads against the development environment. Or the canary environment that I want is pretty much the same as one production environment, but it's not multi-home across multiple geographic regions. And so you have this ability to take your declaration and make small changes on it to produce a bunch of different environments that are basically the same, but individual developers can spin up their own development environments, clones of the same thing. You can move to a canary environment. You can move that canary environment into a production environment. That's much, much harder to do if the world that you're living in is one where you don't have that formal representation of what the desired state of the world is. It also, I made a point a little bit earlier about modularity, but it facilitates reuse as well. So if I have a really good configuration of a database, I can make that something that my company has, right? I can make that declaration of the desired state of a production-ready, multi-master read-slave MySQL, a unit in a library of tools that no developer ever has to think about again, right? And that's really, really powerful. It's just as it was powerful in software to have that library of objects that you can draw from and never have to think about how you implemented that algorithm, it's powerful in configuration management to have that library of templates that you can draw from and include into your configuration. All right, so that sort of concludes the part about declarative management. The next piece that I think I want to talk a little bit about is to talk about the use of containers. So just a show of hands, because I'm just always curious, how many people out there have heard of Docker? How many people have actually launched a Docker container? By about half. How many are actually using Docker or some other container in production? Probably down to, yeah, all right. How many are thinking about using Docker in production? Cool. So, Google actually has a really long history of containers. The original process C groups patches that were pushed into the kernel came from Google engineers in support of Google production workloads. There is a project called Let Me Contain That For You, or L McTuffie, that sort of exposes, is an open sourcing of a lot of the infrastructure that we built to run containers on out in production. So you can find the GitHub repositories up there. You can go up and take a look at that. In some ways, it's analogous to LXC, the layer that Docker is built on top of, and so it doesn't have some of the usability that Docker has. They've done a really, really great job of creating an environment that's really, really easy to use. I hung out with them some, and they're really great guys. But I encourage people to check out LMCTFY if they're interested sort of in the way in which Google is using containers. And just as we've been really excited, I think, to see the interest in declarative management that tools like Salt have really brought to the configuration space, we're pretty excited to see the open source community starting to take a look at containers and see the value that containers afford you. And one of the really primary values that I think containers provide you with, I was mentioning this earlier, is that in the Google production environment, we can have a separation between the people who are in charge of managing the physical machines and the people who are in charge of managing the software that runs on those machines, right? The people who manage the physical machines, the physical hardware that we run, they can do a kernel upgrade, they can do library upgrades, they can upgrade the shell tools that are on there, and they don't have to care. They will not affect my jobs. My jobs run inside a container. That container carries with it all of its dependencies. The version of libc that is running on the physical machine, I don't care about. The kernel that's running, unless a bug is in the kernel that affects my container, I don't care about. And likewise, I don't have to worry about NTP. I don't have to worry about all these sort of like base level physical machine daemons that are in charge of just kind of keeping the machine in a sane state. when I'm worrying about my application, I reason inside the container. The people who worry about physical machines, they reason about the physical machine and don't think about what applications are being served from that physical machine. Who worry about the applications that are running on the machine, I just think about the container that I have and the containers that I've deployed. And that separation of responsibility and separation of concerns really frees people up and frees some of the kinds of entangled problems you'll see where it's like, well, I can't upgrade this kernel because I can't restart the software because I can't do so. That really can paralyze development. The other thing about containers is just as declarative management sort of isolated you and focused you and made things modular, containers likewise make things modular. If you're putting your database and your web server and whatever else onto a single machine, they're kind of overlapped and intermixed with each other, and you have to worry about things like, well, were they all built against the same version of libc? And Debian and Red Hat have come up with package management systems to try and manage these dependencies, but if you isolate your dependencies in a container, you suddenly stop having to care. So you have these very abstract modules that you can simply lay onto a machine, and you know that it works on your laptop, it works on the virtualized machine, it works on the physical machine out in your production environment. It carries everything that it needs with it, and because of that, it's reproducible everywhere. They're also more focused. They only carry with them the things that they need, and that level of focus and that isolation really means that the environment is easier to reason about, and also carries with it a notion of what it's actually supposed to be doing, right? If you look at a virtual machine, if I look at an ISO image that is going to boot a machine, I don't actually know, like maybe the name says something about what it's supposed to be doing, but I don't actually know what it's supposed to be doing. If you look at a container, it carries with it what's within it, and only that thing. So if I look at a Tomcat container, I pretty much know it's Tomcat, right? It doesn't have all of this other stuff that is there just to kind of keep the machine okay and in a healthy state. All right. So then the last piece that I wanted to talk about very briefly is when you make this jump, there's some stuff that you lose. And in particular, although you can set up containers so that you can SSH into them, it's really not the right way to do things. And so, and I'm dead serious about the fact that I spent a long time in production and never really SSH, but in order to do that, we needed to have significant tools to be able to poke into those containers and introspect. And so in particular, you need your container to carry with it not just the software that it needs, not just the functionality that you need to provide, but your container needs to carry with it the debuggability, the introspection tools, the signals that it needs to make available to the outside world, both for monitoring, both for steady state monitoring, but also for poking at it and diving into it. And sometimes this means building custom scripts that are custom web endpoints that are dedicated to your application so you can poke at specific parts of your application. Sometimes that means having containers that carry with them just baseline basic information, like what are the top processes in terms of CPU usage inside that container? What is the state of all of the threads? What is the stack trace of all of the threads in the Java server? The nice thing about Docker is that you can actually create containers like that and inherit from those containers. Just create, again, just as you take a declaration of a really good MySQL, put it out into the world so everybody can reuse it. You can create a really great container for Java applications, put it out into the world, people can derive from that and inherit all of the introspection and debuggability that you baked into that plan. All right, so I think there's a really exciting road ahead. The Google Cloud Platform has built a lot of really exciting services that are based on the knowledge that we've gained over time. I think equally exciting is the fact that we see the outside world building a lot of things that embody some of the same principles and same design ideas that we've built up internally, and I think there's more to come. There are more open source projects out there that are going to be doing really exciting things. So we're really, really, really excited to see where the future lies, and hopefully a convergence of some of the cloud platform tools that we're building and the cloud platform tools that everybody in the open source community is building. I just want to conclude my resources. You can reach me at eburns@google.com. Please come to Eric's talk if you're interested in finding out about sort of the nuts and bolts of the Google Cloud Platform. It's pretty exciting, and if you're using virtualization or even thinking about virtualization or a bunch of other things, come to talk here where we have a city. I'll be around. I was at the Google booth yesterday. I'm not sure if they're still giving one today, but if there is, I'll be there. And please feel free to come up and say hi. So that's it. Thank you.